Hi there, thanks for joining us. This is Space Nuts, where we talk astronomy and space science every week on various topics. And the topics of the day this week include meteor showers. There's one happening as we speak and another one coming up, which we'll be talking about. The Mars Escapade Mission is on its way. We talked about that, I think, a week or two ago, wondering, because they were running into a bit of trouble, but I think they're all systems go now. But this is not all systems go. This is involving Chinese astronauts that are stranded on their space station. And we're going to chase some stars using a process called gyrochronology. That's all coming up in this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us again to go through all of that is Professor Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Hi, Jonti.
Good morning. How are you going?
I am well. Good to see you. Love your T-shirt. Liverpool FC.
Yeah, so much for the outreach T-shirts today. I was groggy when I woke up, and football tops just feel so comfortable.
Yeah, they do,
like
don't they?
For food. Yeah, you pay a lot of money for them, I've got to say that, but they'll last forever. I've still got some from kind of more than 20 years ago that are wearable, which can't say for most of the clothes I buy.
Well, I've got 3 football shirts, and they're all wonderful. Cincinnati Bengals, the Manly Warringah Sea Eagles, and the New South Wales Blues, although I don't get to wear that one very much. And I've got 4 golf shirts that I wear just when I'm playing, and they're all the most comfortable shirts I've got. So I agree with you.
Does remind me of the Sam Vines law of boots, which became a rallying cry in the UK about the cost of living thing. So this is another Terry Pratchett thing, although I think it's like most things Terry Pratchett did, he was drawing on the wisdom of people who came before as well as being very wise himself. But talking about the impacts of poverty and the fact that he could never get his boots to last more than, one season, wandering around being a copper, walking around on the cobble streets of Ankmore Park, and he'd pay $10 for a pair of boots every time. But the toughs, the wealthy, would pay $50 for a pair of boots that would last a lifetime. And so very quickly, he became poorer because he was continually having to buy cheap boots and spending more money on the boots. And this actually became part of a big campaign in the UK for reducing the cost of food and looking after people who are in poverty, led by a really interesting person called Jack Monroe, who's a bootstrap cook, who is someone who's been in quite severe poverty and has had a number of cookbooks about how to eat well at an incredibly low price, from the bargain bin at the supermarkets and stuff like that. And I think for a while that campaign had a really kind of strong backing and made a certain amount of social change, all off the back of the idea that the cheaper something is, the less time it lasts, so the more you'll end up spending in the long term.
Yes,
and football tops are a great example. You get what you pay for.
Well, yeah, absolutely true. My wife spends a lot of time researching ways of reducing our grocery bill. And she found a woman in the United States who does it for a super cheap monthly figure. And she translated that into Australian dollars and went, I'm going to try this. And I think we're up to month 3 and we're doing really well. And it's knocked hundreds of dollars off our monthly spend. It's quite remarkable that we can do it the way we've done it. And I'm very happy with the results. The food's great, and we're doing it uber cheap.
Well, it's always exciting, and I think there's a real conflict with the kind of cost of living crisis, but also the fact that people are working harder and longer than ever these days.
True.
Because one of the ways to reduce your spend on food is to cook everything from scratch, right? You get the veggies and the meat and the spices and make every meal yourself from scratch. But the busier you get, the less time you've got for that. So the more tempting the kind of prepackaged, less healthy, more expensive options are, because you've got that sunk cost, not sunk cost fallacy, but you've got that cost of the time that is available to you, which impacts on the money you have to spend. It's all really bizarre and intertwined, and all this stuff that I didn't realize as a teenager when I was so keen to be grown up.
Well, like when we were kids, you bought food and it costs what it costs to put on the shelf plus the profit margin.
Yeah.
But now they build in all these loyalty programs and points programs and all these other things that increase the price, and it's all hidden. You know, and if you're not one of those customers that joins the loyalty program, you're actually bankrolling everybody else who's a part of it because you're still paying the extra. It's
I know, it's an interesting one online, and we are totally off topic here.
Yeah, we are, but
discussion online the other day about the fact that a certain brand of soft drink over here in Australia is cheaper to buy in 1.25 litre bottles than 600ml bottles. Yeah, everybody will grab the 600ml bottle because of the convenience and all the rest of it. And they typically have the 1.25 litre bottles somewhere else in the store and all this stuff.
Yeah.
Yeah, it's just bizarre how willing we are to just, I don't know, buy into that kind of thing and not even think about it because convenience has a cost.
Yes, but when they put a 30 pack of whatever on the shelf in a big carton at $50, there's no way I'm spending $50 on a carton of Coke or whatever. Yeah, that's outrageous. Okay, we better get on with it. Now, something is making the news at the moment. It's the Leonid Meteor Shower, which has kind of reached its peak now. So by the time some people hear this, it may be long past. But it's a really good one because it's had some big highs in years past. Maybe not so much this year, but it's sort of one of the big ones, isn't it?
It is. I mean, it's another example. I always, whenever there's a meteor shower making the news, and it seems to happen more and more often thanks to the click-starved industry in the Northern Hemisphere wanting every click they can from people on social media. Every meteor shower that comes along gets a lot of stories written about, this is the best one of the year, and you need to go out and see it, and the sky will fall, and I get grumpy. The Leonids are not the best meteor shower of the year, except when they are, and the year is the years when they're not. What I mean by this is that many of the meteor showers we see that are the really reliable annual ones are meteor showers where we are not passing exactly where the comet has passed. We're passing through a tube of debris that has spread out from the comet's orbit over very long periods of time. And so in a typical year, the material we go through has about the same density as the last year, so we get about the same number of meteors. So you can imagine, for example, the Orionids and the Eteroquarids, which are born of Comet Halley, or you can imagine the Perseids born of Comet Swift-Tuttle, where you've got these Halley-type comets that have been trapped on their current orbits or thereabouts for thousands of years. Every time they go around the sun, they lay down trails of dust that currently wouldn't intersect the Earth because the comet's orbits come close to the Earth, but they don't exactly cross us. But over time, that dust has spread out, and you've got these tubes that are tens of millions of kilometers, even 100 million kilometers across in 3 dimensions. So we run through the tube, but not where the comet currently is. And so we're getting the dust after it's spread out for a good long period of time. With the Perseids, you occasionally get enhancements when the comet's relatively nearby because the dust is a bit denser. And that's because Comet Swift-Tuttle's orbit comes a bit closer to perfectly intersecting the Earth's orbit than Comet Halley's does. And so we do get a bit more variability there. With the Leonids, we've got a slightly different situation. The meteor stream itself is younger, which I would argue suggests that the parent comet 55P Tempel-Tuttle hasn't been trapped on its current orbit for as long, so it hasn't had time to lay down as much debris. Yeah. It's also a smaller comet, so it's laying down a bit less material every time it goes around the sun. But the Earth's running into the debris from that comet pretty much head-on, which means that the particles from Comet Tempel-Tuttle hit the Earth's atmosphere at about the maximum speed anything can and still be bound to the solar system. So these meteoroids hit at 71, 72 kilometers a second. And that means they're typically a bit brighter for a given size than other meteor showers. So in other words, we can see the smaller bits of dust, and that helps give a bit of a boost to the rate that you'd see. But typically in an average year, the Leonids would give you between 10 and 15 meteors per hour as a zenithal hourly rate. And the zenithal hourly rate is this magic number that astronomers use to quantify how strong a meteor shower is to compare it with other meteor showers. It is the theoretical maximum number of meteors you would see if you had perfect eyesight, if you had perfectly dark skies and perfectly clear skies, and the radiant of the meteor shower, the point from which all the meteors appear to diverge, was directly overhead. So in reality, whenever you see a ZHR listed for a meteor shower, you probably will see fewer meteors than that in an hour, except for the fact that meteors are like buses. You'll wait 5 minutes and 3 will come along at once. And so with that bit of noise, you may occasionally get an hour where you get a bit higher rate, and then the next hour will be a bit lower. So a typical year, Leonids give you 10 to 15 an hour. But the Earth intersects very well with the orbit of Comet Tempel-Tuttle, which means that in theory, there's a very small chance at some point in the future the thing could hit us, but it probably won't. It's almost certain it won't. A bit like Swift-Tuttle's a similar situation, actually, but Comet Tempel-Tuttle's more pronounced. What that means is that the debris that has been laid down by Comet Tempel-Tuttle in very recent times at previous orbits can actually interact and hit the Earth, if we're lucky, on the first lap after it was dropped or the second lap after it was dropped. And what happens with the dust released from a comet is that it spreads out ahead and behind the comet in its orbit relatively quickly. So if you eject a dust grain from the comet in the forwards direction when the comet's near perihelion, that dust grain will be going quicker than the comet, so will therefore move on a longer period orbit. And by the time the comet comes back, that dust will be behind the comet and it will arrive after the comet. And similarly, any dust that's ejected backwards will be moving slower than the comet. It will have a shorter orbit than the comet, and it will come back before the comet. So what this means is that you effectively get almost like these spears or javelin-shaped streams of dust where there is a lot more dust, which is the dust that was laid down in the previous orbit. And these spikes will be millions of kilometers long, but relatively narrow in space. Initially, it takes them a long time to spread out. And that's the dust that's been pumped into the wider stream that when it diffuses and spreads out will form the wider meteor stream. Now, because these spikes are really, really narrow in space, we either hit them or we miss them. And if we miss them, there's nothing to write home about. But if we run through one of these spikes, we'll get enhanced meteor numbers. And the more material in the spike, the higher the rates we'll get. And that's why the Leonids are the source of some of the most famous and the most spectacular meteor storms of all time. We're talking about years like 1799. 1833 AD is a really famous one because that was a storm that was visible over the Americas with more than 100,000 meteors per hour.
Wow.
Where light in the sky was bright enough to wake miners who were camped outside their mines in tents, and it had the more religious side of people in the US convinced that the apocalypse had come, that the end times had arrived.
Yeah.
The Judgment Day had come, people were terrified. So that was utterly fascinating, but at the same time, that was very much kind of the birth of modern meteor science, because people studied it, figured out what was going on. The Leonids have a really important part in our meteor history. There were big storms in 1965 and 1966 after about a century of nothing. There was big storm in 1866. Then the next two 33-year periods, the comet's orbital period's about 33 years, passed with a whimper rather than a bang. 1965, nobody really expected anything, but there was a big outburst of bright meteors. And then in 1966, there was a big storm. So by the time the late 90s came along, we had this huge industry of researchers studying the Leonid Meteor Shower, trying to predict what would happen in 1999, 2000, 2001, 2002, and developing this kind of modeling theory based on those javelins of dust, effectively, based on modeling the dust after it was ejected, to predict when we'll cross trails. And they did a fairly good job of predicting the strength of and the time of the big outbursts, the last one of which was in 2002, where there were a few thousand meteors per hour. Since then, rates have gone back to normal, and occasionally now we have the potential of crossing streams. Now, the comet doesn't pass perihelion for another 8 years, so we're still far away from that, so we wouldn't expect a big outburst in the next year or two. Yeah. But we're starting to get to the point where we might clip the ends of these spears in space and start seeing enhanced rates. Now, the bad news for everybody is that Jupiter and Saturn are conspiring to nudge the orbit of the comet around, and we probably won't get another great Leonid storm until 2099. But we will see some enhancement in rates through the early 2030s and again in the early to mid-2060s from the stream. All that comes back to this year's shower. This year's shower was forecast to be fairly average, but we did have 3 or 4 potential very old stream crossings forecast. One back on the 9th of November, and I've not seen anything about that. That would be very weak because that was dust laid down in 1167. Wow. A small outburst on the 15th, which I've seen no reports of. That was the 1633 dust stream. But then a couple of hours after the forecast peak, which is tonight Australia time as we're recording at early hours of Tuesday morning, there is both the regular maximum but also a potential crossing of a couple of dust streams from 1699. Now, none of these will really boost the rates above that 10 or 15 per hour, but they're a really important test for our models of how well we can predict where these dust streams will be and how dense they'll be. And it's not the most straightforward process. People who are doing this research have to track the comet's orbit back in time, which is where ancient comet observations are really useful, old observations of the comet to pinpoint it. They need to then have a model of how the dust grains are ejected from the comet at each perihelion, how the non-gravitational forces like radiation pressure, the Ponting-Robertson effect, all these effects push the dust grains around, and they have to then run them forward in time with the gravity of all the planets and all those non-gravitational forces to figure out where they cluster near the Earth's orbit. So it's very complex modelling, and anything we can do to ground truth that by getting observations of the meteor shower are really useful. So if we see an uptick and we see the rates are a bit higher or a bit lower than predicted, that allows us to refine the models so that when it comes to the bigger potential numbers, which next year could be a slightly better year, potentially up to 30 or 40 an hour, depending on some of the models, for example, we can have more confidence in that. So that's really what's going on with the Leonids. So while I get grumpy about the stories encouraging people who are not fans of astronomy normally to go out and spend their nights out in the northern hemisphere cold, in the southern hemisphere heat and humidity and rain that we're getting at the minute, I get a bit grumpy because this isn't the shower to watch for that. If you're not a mad keen meteor fan anyway, this isn't the one to watch. What you should do is wait a month and look at the Geminis, which we can talk about in just a little minute.
Yes, and we might as well just jump straight into that because they're due mid-December.
Yes. So, I always love meteor showers. Meteor showers are part of what hooked me in and kept me in as a kid. So I've always got a soft spot in my heart for them. And back in the 90s, we had the Perseids were clearly the strongest meteor shower of the year from the northern hemisphere, and that's a shower that's active in August, and the caveat is we don't really see that very well in the southern hemisphere.
Yeah.
We then have the Quadrantids at the start of January, which are one of the year's best three showers, but are very hit and miss. They're only at their peak for a very short period of time, just a few hours, and they are, again, very much a northern hemisphere-only shower. And then we have the Geminids, and the Geminids were first seen, I think, in the late 1800s. And ever since, they've been getting stronger. So they started off as one of the year's moderate showers, and they've grown in strength. And by the early 1990s, when I was watching them, they had a zenithal hourly rate, the ZHR, of about 100 per hour.
Yeah,
that's now up to 150 an hour. And they are undisputedly the king of the meteor showers in a typical year, unless we get like a meteor storm from one of the episodic showers like the Leonids or the Jacobinids or the Andromedids or something like this. In a normal year, the Geminids are the king, and they're very, very reliable. They're also the only one of those big three meteor showers that is easily seen from the southern hemisphere. The northern hemisphere still gets the best views, undeniably, because the radiant for the Geminids is north of the equator, so easier to get high in the sky from northern latitudes, rises earlier, stays up longer, all the rest of it. But even from Australia and other southern hemisphere locations, the Geminids are really good. They're at the peak on the nights of the 13th and the 14th of December. The night of the 13th into the morning of the 14th is the best for most people. For us here in Australia, because we're so far ahead on the clocks, the rates will be building to their peak before dawn on the morning of the 14th, that's the night of the 13th, and then falling away from the peak very slowly on the evening of the 14th, the peaks during our daylight hours. But the Geminids have quite a broad peak as well, so they're worth watching for a couple of days either side of maximum. Well worth going out camping, getting away from street lights, getting to a dark site. If you're at my latitude in southeast Queensland, you'll see the first Geminids from about 9:30, 10 o'clock at night, but the best rates are later in the evening. The peak rates anywhere on the planet are about 2 a.m. or 3 a.m. if you've got daylight savings, like the people in the southern states of Australia. You move your clocks forward an hour, you move everything forward an hour.
Yeah.
But the further north you are on the planet, the earlier you can start watching. And for me, growing up in the UK, the radiant was above the horizon pretty much after sunset and was above the horizon all night. So even as a 12-year-old, when my parents were grumbling that I should do my homework and I needed an early night at school the next morning, I could still get a decent show before I went to sleep. Nowadays, if I was still in the Northern Hemisphere, I'd be able to stay up all night because I'm a grown-up and I can pick what I do, but it would be cold and miserable, so I might not do that. But it is a global opportunity to see a really good meteor shower, and they are the best one of the year. So yeah, book your camping, book your holidays, find a dark site, and don't blame me for the weather.
Yes, you can never do much about that. You just got to keep your fingers crossed. But a couple of meteor showers to keep an eye out for. The Leonids happening as we speak-ish, and the Geminids in mid-December. You can look up the times and dates and etc. Online. This is Space Nuts with Andrew Dunkley and Jonti Horner. Let's take a break from the show to tell you about our sponsor, NordVPN. Now, if you've ever felt like your online privacy is slipping through the cracks, then you're not alone. Hackers, scammers, harvesters, they're all out there trying to get your private info, whether that's your passwords or your personal details to sell on the dark web or to use themselves to access your bank accounts, credit card details, and who knows what else. But you can protect yourself with NordVPN. You can take control at home, or more importantly, when you're out in public using free Wi-Fi. Right now, using the exclusive Space Nuts offer, you can receive 4 extra months for free on a NordVPN.com plan. NordVPN encrypts your internet connection, hides your IP address, and offers access to over 7,700 servers around the world. Plus, with features like Threat Protection Pro, MeshNet, ultra-fast speeds via Nord links, your digital life stays private and efficient. So don't miss out. Visit nordvpn.com/spacenuts and enter the code SpaceNuts to claim this deal. Remember, there's a 30-day money-back guarantee, so it's risk-free to try. Stay safe, stay private, and browse with confidence. That's nordvpn.com/spacenuts and use the code word spacenuts. nordvpn.com/spacenuts.
Roger, you're loud and clear here also.
Space Nuts.
Now, this is a great story. The Mars Escapade Mission has lifted off successfully, and this is a good story for a number of reasons, in fact, Jonti.
It is. This is one where I feel like I'm going to be jumping off in several directions all at once, so it's almost like 3 mini segments in a way.
Yeah.
We spoke last week about the US shutdown and the issues it was causing for airspace over the US and the resulting ban on any rocket launches other than between 10 p.m. and 6 a.m. And of course, fairly quickly after we talked about it, the shutdown was finally sorted and agreed and fixed. My understanding is that now everybody's trying to get the wheels turning on the bus again, so trying to get everything back into action. But that air traffic control restriction was still in space because it takes time to ramp things back up. This was relevant for spaceflight, particularly because of this NASA mission. Now, NASA has been shut down since the 1st of October, but fortunately this mission was already out of their hands, in the hands of the launch provider, so the shutdown wasn't going to stop it. But where it could delay it was that the rocket needed to launch in daylight hours for the Earth to be pointing in the right direction.
Yep.
And so, with the shutdown happening, they were on dodgy ground. They were hoping to launch just before the shutdown came in, but that launch got scrubbed. Then they got a waiver to launch during daylight hours because of special exemption from Florida, and that launch got scrubbed. But it finally managed to launch on Friday. This was launched by the commercial provider Blue Origin, whose New Glenn rocket put the thing up into space. And it was a noteworthy launch for Blue Origin, because, hey, look, they've launched something that is going beyond the Earth-Moon system that's going to Mars. I mean, that's really cool anyway. But also their New Glenn rocket, the first stage, the lower stage, the big chunky thing that does a lot of the work to get you most of the way out of the atmosphere. Once that had detached from the second stage, it plummeted back down towards the Earth. And a couple of minutes after that stage separation, it turned its engines back on, stood up on its tail, and landed safely on a barge in the ocean called Jacqueline. Now, we're kind of used to SpaceX managing this. They've been doing this for a while. But that ability to land and recover your boosters to reuse them is actually really, really important. It's one of these things that allows you to reuse your boosters, and so therefore, by reusing them, you reduce the cost of future launches, which is part of what makes commercial spaceflight feasible. And this is only the second company ever to manage this kind of soft landing, safe landing type process. So it's really remarkable that they actually achieved it. There's some fabulous videos out there. People are really thrilled watching these things happen. And it's a fabulous technological achievement. So it's a +1 and a tick for Blue Origin. They're very pleased with their role on this. Escapade itself is really interesting. It's launching out of sequence. Normally we get launches to Mars in a big batch every 26 months or so. And the reason for that is that Mars and the Earth move around the sun with periods that are similar enough that Mars is closest to the Earth every 26 months or so. Now, if you want to get the cheapest, quickest flight to Mars, you don't launch when the Earth's on the opposite side of the sun to Mars, because that means you've got to go the long way around. So people tend to wait for the launch window when they can do the shortest, quickest trip. And instead of taking 12 or 18 months to get there, they can get there within 6 months, and it's all nice and easy and cruisy. And the next launch window doesn't actually open until about this time next year. Escapade, though, has an interesting launch window in that it's not launching directly to Mars. It's doing something different. It's going to launch out to the second Lagrange point, the Sun-Earth Lagrange point number 2, which is beyond the Earth in its orbit, between the orbits of Earth and Mars, about 1 million kilometers further from the Sun than we are. And this, of course, is where a few space observatories like the James Webb Space Telescope are hanging out, spending their time. Escapade is going to hang around there for about 12 months. Then this time next year, as the launch window to Mars opens, it's going to drop back out of the Lagrange point, swing towards the Earth, get a gravity assist from the Earth, and boost off towards Mars, getting there in about September 2027. Is that right? September 2027? That sounds about right. Yes. So it's going to take the long way around, but this is a very economic way of doing things, and it also opens up the possibility of not having to wait for that launch window and being at the whims of the weather and stuff. You know, the worst case scenario is you're launching from one of these launch platform areas where they get cyclones, they get hurricanes or typhoons, and your launch is scrubbed, but the launch site is then damaged, and by the time it's repaired, the launch window's closed, and you've got to wait 26 months. And that's not good for anybody, particularly the staff who are waiting to wait on the mission. So if you now have something where you can launch missions to Mars at almost any time, and they can just go into a holding orbit, do some extra work while they're there because nobody likes to be idle, and then boost on off to Mars, that's got really interesting implications for the future of Mars exploration in particular, but also potentially exploring the other planets in the solar system. As the spacecraft goes out there, whilst it hangs around at the L2 point, it will be earning its keep. It'll be doing observations of the solar wind and measurements of that, which will serve the purpose of testing all the equipment on the spacecraft, and also send back extra awesome data that scientists who study space weather can use. And then it'll drop and boost off towards Mars. So that's all very, very cool. Another aspect of this that's really awesome is that it's a commercially built spacecraft. So it was built by Rocket Lab, who are a big NASA partner. And so you've got an entire mission to Mars for about $80 million. And that includes about $7 million worth of delays because NASA didn't want to launch until Blue Origin had confirmed that they could launch the rocket and get it back safely. So this is a mission to Mars for about $80 million, which is hugely cheaper than previous Mars missions. So we're seeing again, not just from the launch, but actually from the construction of the spacecraft here, the real benefit you get when you finally get to the point where you can commercialize space travel and space flight. Because by bringing in commercial partners, by being able to build things using off-the-shelf components, things like that, you bring the costs hugely down, and that enables far more science. So that is really exciting and reassuring to me as well, the fact we'll be able to do missions like this in the future for cheaper. And the final bit, of course, is what these things are actually going to do. There's 2 spacecraft called Blue and Gold who are going to fly in formation. When they get to Mars, they're going to gradually lower their orbits until they're moving on identical orbits, one leading the other, a bit like Ring-a-Ring-a Roses or something, one going around in front of the other one. And they're going to spend about 11 months studying how Mars's atmosphere responds to the solar wind, really trying to unpick what happens in terms of the bleeding away of Mars's atmosphere to help us try and get a handle on why Mars is no longer the warm, wet Mars that it once was, with a thick atmosphere and abundant oceans.
Yeah.
Trying to get a feel on those processes that stripped the atmosphere away to leave it the kind of arid husk it is today. So that's going to be really cool science. So it's, like I say, it's one of these stories where there's so many different aspects that are individually fascinating. It's hard to know where to look first, essentially.
Oh, yeah. This one's really exciting. And it's it's going to be in the news over the next few years. And those mysteries that have always surrounded Mars, if we can get answers to those, that will be really valuable information. But it'll also close the book on a couple of things that we've really been trying to figure out for a very, very long time, because we know historically Mars was warm and wet and, may have had life. What happened? There's stuff we do know, but there's still mysteries. I'm just reading here the green auroras that Mars has. They can't figure that one out. So hopefully they'll have an answer for that as well. So
much more
plenty to learn.
It's also got a really expanded scope to that, in that we're going to be in a position to start actively searching for evidence of life on planets beyond the solar system fairly soon. I mean, we are trying already.
Yeah.
But as our technology gets better, we'll get better and better at looking at these planets we find around other stars to look for evidence of life. And one of the big questions, particularly when it comes to planets around M-dwarf stars, the little tiny red dwarf stars, is whether planets could actually hold on to their atmospheres for long enough for life to get established and to thrive. And that's kind of backed up. If you look at the story of the planets around TRAPPIST-1, there was huge excitement about those from people who were overblowing them as being potentially the best targets for the search for life elsewhere. When people looked at them with James Webb, they don't have atmospheres, which is kind of a problem if you want to have liquid water on the surface of a planet. Not having an atmosphere is a bit of a killer.
Yeah.
So this Escapade mission, by telling us more about the process by which Mars lost its atmosphere and lost its oceans, that data is not just helpful in putting the Earth into context, it's not just helpful in looking at the history of life on Mars potentially, but it's also really useful data for as we look at planets around other stars and try and figure out which are the best targets for us to look at from the point of view of the search for life. And it will hopefully kind of help us figure out whether red dwarf planets are viable or whether we should just ride off planets around stars smaller than a certain mass entirely when we're going to have very limited facility to study planets and to look for life on them. So it's a mission with a scope beyond just a solar system, I think.
Yeah, I'm not going to wait for the results. I've already decided in my new sci-fi novel that the planet in question does have an atmosphere and it is orbiting a red dwarf. So
yes,
all bets are off. But it's going to be a great mission. So we'll keep an eye on everything going on with that mission to Mars and beyond. Let's move on to our next story, Jonti, and this involves China, the Tiangong space station. People go to and from that on a fairly regular basis. We don't hear much about it, but we're hearing about it now because there's a few people stranded.
Yes, and it's happened again, of course. We had this back in 2024 with the International Space Station and the NASA astronauts Butch and Sonny, who were up there for an extended holiday, because they were stranded there because of the problems with getting a vehicle up there to bring them home effectively. It's almost a little bit like history repeating itself. So the backstory here is that the new crew on the Chinese space station Tiangong arrived relatively recently on the spacecraft, on the delivery vehicle, I guess, on the bus called Shenzhou 21.
Yeah.
And normally that would stay there to bring them back home again. And the previous crew would go home on their spacecraft, which was Shenzhou 20. But Shenzhou 20 was victim of a space debris strike and was considered unfit to return people home. And there were concerns that it wouldn't get back down in one piece, which is very similar, in fact, to what happened in 2024. And so the crew who were on Tiangong got onto Shenzhou 21, returned home, and that leaves the current crew kind of without a lifeboat, without a means to ride home safely.
Yeah, it's sort of like taking someone else's taxi, isn't it?
It is pretty much. And so they've got to wait for the next taxi off the rank. Now, the reason this is a bit shorter of a segment is that China are much more close-lipped about what's happening, particularly when a story's live. And we've seen this with their moon missions and their Mars missions before. They don't tend to tell you much about them beforehand. They wait till they're successful, then they talk about them. Yes. Now, there are space experts who've been interviewed about this, and the story is apparently that China will typically keep one of their Long March 2F rockets, their big rockets, and a backup Shenzhou spacecraft in what has been described as a state of near readiness. In other words, it's not ready to go right now, but in theory, they should be able to get the lifeboat up to Tiangong within about 8.5 days of realizing there's a problem. which is probably not hugely comforting to the people up there. But in reality, 8.5 days is a hell of a lot quicker than we got Butcher and Sonny back.
Oh, yeah.
What Chinese officials have said is that they've said that Shenzhou 22, which is the next taxi to go up there, basically, will be launched to Tiangong at an appropriate time in the future, which is fairly close-mouthed. But the likelihood is that that will go up without a crew. It'll be an autonomous thing so that it can latch on and give these people a ride home when they're ready. So, hopefully they will get back on schedule, and they'll certainly have the lifeboat there if they need it a lot more quickly than Butcher and Sonny would with their extended stay and their long, unexpected fly-in, fly-out adventure.
Yes, indeed. But it also underlines the risks that people take going into space. It is a hostile environment, and it sounds very much like the damage that they suffered on one of those shuttles was probably caused by something else we sent up there some time in the past.
Yeah. And this is going to be an ever greater risk the more stuff we put up there. I mean, it goes back to the discussion we had about space elevators last week. The more stuff we put up there, the more you have to learn to dodge if you are something that has people on board, which probably doesn't bode all that well for the plans that we kept talking about a few years ago about possibly having space hotels up there and stuff like that, because the space hotel industry is probably not going to be all that impressed with the growing use of commercial space for internet satellites and things like this. So there's really interesting challenges in our future, and this is just highlighting a problem that will become more and more significant in the years to come unless we get better legislation around the use of space.
And the rules should consider, cleaning up your own act. I know there is a code requiring you to, look after your own stuff when it's been dealt with or you've finished using it or whatever, and deorbit it and burn it up. But that's creating another problem, because all this stuff that burns up ends up staying in the upper atmosphere. And we don't know what that's going to do in the future.
No, it's awfully complex. And I mean, the other thing is that whole thing about bring stuff back into the atmosphere to declutter space is all well and good. But if a satellite gets smashed by a bit of space debris, you can't control where the debris goes.
Exactly.
It isn't really the responsibility of the people whose satellite was smashed, you'd have thought, to account for all of the debris that was generated by their satellite being hit by something that wasn't theirs. I mean, that would be an interesting claim to put in for the insurance. Normally, if you're in a bit of a car bump, you claim from the other driver's insurance. That's how it works. But a lot of the debris up there isn't like it's catalogued that this is a property of the US, this is a property of SpaceX. It's a bit of debris. There's large amounts of debris up there that is too small for us to effectively track. And
things as small as paint flecks, but they're moving at thousands of kilometers an hour.
Yeah, it's challenging. And I think we take space and our use of space for granted nowadays. It's not like the 1960s where people accepted that human spaceflight was dangerous, people will die, we just get on with it. There's been a big transition. I think that was a big part of why we stopped going back to the moon, or rather why it's taken so long to go back, should I say. And similarly, it's why the shuttle program eventually came to an end. It was that shift in public consciousness from when the Challenger disaster happened, when people were like, this is very sad, but we need the space shuttle, to when the second disaster happened, and that was too much. We've had this shift in the public consciousness, and it's kind of grounded in that idea that space is easy, and it really isn't. This is just a reminder that space is hard. There are going to be problems in the future. And it's an interesting challenge to balance off the needs of commercial enterprise and the needs of human spaceflight and the regulation involved, when pretty much everybody involved benefits from it not being that regulated. So there's not much of an incentive. It's a bit like asking fossil fuel companies to legislate about climate change or cigarette companies to legislate about cancer.
Yeah.
It's not in their interest to do so.
No, but we do wish the Chinese astronauts well, and I'm sure they'll be home pretty soon. We hope so anyway. I just thought I'd better check, because we don't call Russian astronauts, they're cosmonauts. Chinese astronauts are officially astronauts, but they're also known as taikonauts. Yeah.
It's a really interesting one, and I'm not is it etymologist or entomologist? One of them's about words and one of them's around beetles, but I'm not into the science of the study of words. But there has been this idea of every nation having its own unique name for those that they send to space. where you have cosmonauts and taikonauts. It does make me wonder if Australian ones would be skippinauts or hoppinauts or...
I'm thinking digger-nauts.
Yeah, drop-bear nauts. Interestingly, there was a story which is sufficiently out of my field that we're not talking about it, but there was a story that cropped up on the BBC last week that somebody has discovered drop crop fossils. Drop croc fossils. So anybody who's been to Australia or knows Australians knows about drop bears, which are a terrible pest, and we have to deal with them.
We do.
They're a nightmare. You should look at the Australian Museum's drop bear.
I mean, people worry about spiders and snakes and jellyfish. No, that's the drop bears.
Something to share on the Facebook group would be the Australian Museum's drop bear page, because they've got a location map for them and a large description. So for those interested in drop bears, can really strongly recommend that. But there was an article came out in the BBC, and I think a few other reputable science journalism outlets last week talking about fossilized drop crocs. So the idea that there was a species of crocodile in Australia a few tens of millions of years ago that used to climb up trees and drop hunt in the same way leopards do. So you'd have crocodiles jumping out of trees onto their prey.
Oh, my word.
So, yeah. Droppanauts would probably be an appropriate Australian.
Yeah. I'm actually looking at the drop bear map.
It's fabulous, isn't it?
That's
I love this.
I love the shape of the location in Central Australia. That's a ripper.
Absolutely. So always remember to wear your hat with the corks on.
Oh yeah, that keeps them away. They don't like corks. Okay, moving on. This is Space Nuts with Andrew Dunkley and Professor Jonti Horner.
0G, and I feel fine.
Space Nuts.
To our final story, and this is a bit of a fun one. The Pleiades. What's going on with them?
Well, the Pleiades are...
Sorry. No, the Pleiades are the subject, but the topic is actually chasing stars using gyrochronology. That's gyrochronology. Yeah.
A couple of other things. It's the beauty of being able to bring together different fields of astronomy with different data. It actually ties into a fabulous Australian project that I was part of for a good long time that I need to get back involved with at some time, to be honest, that I think Fred's been involved with a bit as well, called GALAR, which is galactic archaeology with Hermes. And this is a means by which we can look for stars that form together and do archaeology that digs into the history of star formation in the Milky Way by looking at the spectra of stars, figuring out their compositions, looking at the abundances of elements within those stars to find their stellar twins, the stars that they formed with long ago that have that same chemical fingerprint of their original formation. This story links to that, but it's not actually using GALAR data, it's using a variety of other data. The story is that we have the most famous star cluster in the night sky, the Pleiades, the Seven Sisters. To people in Japan, this was Subaru, but basically every culture across the planet can see the Pleiades. They're within about 25 degrees of the celestial equator. They're not very far from the ecliptic. In fact, you often see beautiful photos of the moon or the planets near the Pleiades. So they're visible from basically the entire inhabited surface of the Earth. They're very beloved of people. There's a lot of wonderful cultural stories that talk about them. There was a fabulous study looking at the traditional knowledge of the traditional owners here in Australia from some of the groups who talked about the Pleiades being protected by the bright star in Taurus Aldebaran, who was a wise woman protecting these young women from a man with fairly voracious appetites in the form of Betelgeuse in Orion, and Betelgeuse and Aldebaran fighting using fire magic, and the magic building up and flaring off and them having this fight, which is a fabulous story, but it also ties into the fact that both Betelgeuse and Aldebaran are variable stars, and this story is taking their variability into account in part of the folklore and the storytelling of what is culturally right and wrong, what is the right way to behave, and in doing so, encoding astronomical data. So that's a study that my colleague Dwayne Hamacher down at the University of Melbourne was telling me about that he was involved with, which is fabulous work. So the Pleiades are really important to cultures all across the globe. They're very beloved. They're very easy to see with the naked eye. Depending on how good your eyesight is and how good your location is, most people will see 6, 7, or 8 of them. You know, I can normally pick up 8 or 9 on a really good dark site, 6 or 7 when it's less so. And that's why for a lot of people they consider the Seven Sisters. There is a guy in Italy who used to claim he could see 82 of these stars with the unaided eye, and I think it's fair to say that nobody believed him. If you look at the cluster with binoculars or a telescope, you see far more. So the stars we see with the naked eye are the ones that are the superstars. They're the most massive, the most luminous, these bright, beautiful blue stars. Now, what we know about star clusters like the Pleiades, like the Hyades, like Praesepe, the Beehive, is that these agglomerations of stars are stars that formed in the same stellar nurseries. They were all born together, but the cluster does not have enough mass that it will stay discrete and held together forevermore under gravity. Unlike globular clusters, which are as old as the galaxy and are very different, they're kind of a million stars packed into a small space. Open clusters are typically a few hundred or a few thousand stars. And so what tends to happen, a bit like young kids, is, they hang around together while they're at school, while they're at nursery, but then as they move into their adult lives, they disperse off and go their separate ways. And what that means for clusters like the Pleiades is gradually the stars towards the outer edges of the cluster will gradually get nudged and tugged so they fall away from the cluster, start to move freely through the galaxy separate to the cluster, and the cluster disperses. And it kind of gets whittled away from the outside in. And what we see with the Pleiades on the sky is the core kernel, the very central area which has the most massive stars in all hanging around. And the idea is that when the Pleiades were younger, there were more members still bound to the cluster was bigger, and the cluster's been shedding members over time. And that's fairly well established, but it's really interesting to think about where those members have gone. It's like looking back at a band from youth. What did they do now? Where are they now? Those old TV shows. Where are the former members of the Pleiades? Now, this has led to the concept of the Greater Pleiades Complex. So if you could, with good enough precision, get lots of data about all the stars in the sky, you could, in theory, identify those ones that formed in the Pleiades but have disappeared. And that's what this work has tried to do. There have been previous estimates that have just looked at the positions on the sky and the motion of the stars to see if that motion is compatible with them having formed in the Pleiades. Are they moving through space at about the same speed as the Pleiades, but moving away from the Pleiades at such a speed that they would have been near the Pleiades when they formed? Now, that's problematic because it will capture a lot of stars that just happened to be in the vicinity of the Pleiades when they formed, but were already there. They were near the star-forming region, but they were not involved. I guess it's a bit like, trying to figure out all the babies that were born in a hospital on a certain day by saying anything that was within a kilometre of the hospital could potentially have been a baby that was born there. But you've got a lot of people commuting past on the highway. At the time, just so happens. What this new study has done is it's taken data on the stars from NASA's Exoplanet Survey satellite tests, the Transiting Exoplanet Survey satellite, that's been scouring basically the entire sky. It gives you a wealth of data on how stars behave. You've got the Gaia spacecraft, which is a European Space Agency mission that has stopped observing now, but is still providing lots of data updates, and we're looking forward to DR4 from that next year, from the exoplanet side of things. But Gaia has given us incredibly precise positions on the sky, incredibly precise distances, and incredibly precise movement information about the stars. So we know very accurately where they are in space and how they're moving. And the team behind this work have brought into it the third bit of information, which is gyrochronology. So this is an attempt to figure out the ages of stars. And once stars are on the main sequence, once they're in the prime of life, it's very challenging to figure out how old they are because they sit there basically doing very little, changing very little. It's like Perry the platypus. He's a platypus. They don't do much. It's that same kind of idea. Just sits on the main sequence, trundling along, barely changing. Now, there are means like asteroseismology, measuring the wibbling and the wobbling and the starquakes on a star that can tell you a lot about its interior and allow you to infer an age. And that's what some of my colleagues at UniSQ do. But that's very time-consuming and challenging. So you kind of have to do one star at a time and dedicate a lot of observations to do this because you've got to measure all the different frequencies at which that star vibrates and wobbles. So that's good for individual stars, but it's not good for a population survey like this. So going back about 20 years, a couple of researchers noticed that for stars where we had relatively good understanding of their ages, that were less massive than a spectral class of F8. So these are sun-like stars or a little bit more massive, going all the way down to red dwarfs. They found that there is a broad relationship that the older the star is, the slower it spins. And this makes sense. Our sun is shedding angular momentum with the solar wind as material is flung off. So it's gradually spinning down And it's a very, very, very slow process. But given that stars live very long lives, it's something that is quantifiable and measurable. So the idea here is that if you find stars that are spinning quickly, then they are probably young. And so the team involved with this study took this master list of all the stars that have positions and velocities compatible with them being near the Pleiades when the Pleiades formed, and did an age check on them. They ID'd them effectively. They said, how old are you? Measured the spin rates, which is the kind of information you can get from missions like TESS. And they set a limit that I think the stars had to be spinning with rotation rates of 12 days or shorter to be young enough. That allowed them to filter the list down significantly and left them just over 3,000 candidate stars that are probably members of this greater Pleiades complex. And those stars are spread all over the night sky. They're concentrated through the Milky Way, through the plane of the galaxy, and that's perfectly making sense because star clusters tend to form very close to the plane of the galaxy. They tend to be dynamically kind of cold. They tend to be on very flat orbits. So these things have spread out along the plane of the galaxy in both directions away from the Pleiades of the sky. But because some of these stars are relatively nearby to us, some are passing above or below us. So basically any direction in the sky that you look, you might see a star that was born with the Pleiades tens of millions of years ago. It used to be that the Pleiades were said to be about 65 million years old. I think the accepted wisdom now is that they're about 100 million years old. And that gives you a lot of time to move a very long way away from the cluster if you've escaped.
Yeah.
So these stars are just spread all across the sky. And it's a really lovely insight into the lives of these clusters and to the way that we can do kind of stellar and galactic archaeology effectively. We can get insights into the formation history of our galaxy and how clusters form and evolve. It's really beautiful, and it is, my partner's big into archaeology. She loves watching Time Team with Tony Robinson, and this is effectively like a Time Team episode in the sky.
It is fascinating. We don't think about it much. We look up, most people probably just look up at the stars and go, oh, they're pretty. But they don't think about how over time they've moved around. And it goes back to a story Fred and I talked about more than once, and that is that our sun was probably a member of a binary and had a sister star or a twin that we are still looking for. It's out there somewhere probably, but we haven't found it yet. But it's a fascinating study, and I like the sound of it. You can read all about it at space.com, or you can go to abc.net.au on their science pages and check that out. We are done. Jonti, thank you so much.
That's all good, and sorry for the unexpected interruption in the middle there, but insurance companies got to do what insurance companies got to do, unfortunately.
They have got to do that, whatever they do. I thought of another name for an Australian astronaut.
Yes?
You ready? Yeah, a Yobonaut. I reckon that'd probably be a winner.
Well,
Yobonauts.
Where you recruit them from, you could have larriconauts.
Larriconauts?
Or bogonauts.
Bogonauts, yes. Well, we have a shire west of us called Bogan Shire. So,
and of course, if you send any pets to space, you could probably have bluey-nauts as well.
Bluey-nauts, yeah, that'd be popular. And you can't wear boots to space; you got to wear thongs.
Yes,
which everyone else calls flip-flops or jandals or something, but we've somehow managed to turn a pair of underpants into footwear.
Yeah,
but anyway,
it was a constant source of confusion for shop owners in the UK when Aussies came in and went into a shoe shop asking where they keep their thongs. Yeah. And it was always quite entertaining seeing people's faces as the staff kind of react.
Yeah, that's a whole different story. Yeah. Anyway, Jonti, thank you so much. It's been a pleasure.
That's an absolute pleasure. Thank you for having me.
Always good. Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. And thanks to Hugh in the studio, who didn't much help today because, he's got a second job. He's an Uber driver, and he got a text to pick up some Chinese astronauts from the Tiangong space station. So he's on his way. Don't forget to visit us online at Facebook, the Space Nuts podcast group, or the official Space Nuts Facebook page or Instagram. You can also visit our website and have a look around while you're there. Maybe pick up a Christmas present or two. It's coming up to that time of year, and if you're not sure what to buy, if you've got one of those people you don't know what to buy them, Go to our shop and see what you can find. That's spacenuts.io. And from me, Andrew Dunkley, thanks for your company. We'll see you real soon on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.